Okay, so number 1 says, suppose a car engine exerts a force of 800x times 1 minus x pounds when the car is at position x miles. So kind of a weird equation, but all right, compute the work done when the car travels its first mile. All right, so if I am graphing this, this would be my y value, and then I'm going from x equals 0 to 1. So I'm finding the area under the curve. So my work is okay, it's like that. Okay, so let's multiply in. So I'd have 800x minus 800x squared. And don't pull out an x. All right, so when I'm integrating, I get 400x squared minus 800 over 3x cubed, going from 0 to 1.
Why can't you just pull the 800 out front?
You could.
Just do x.
Yeah, you can pull the 800 out. You can't pull the x out. That's what someone said.
Steve.
What?
All right, so I get 400 minus 800 over 3, and then be minus 0. Okay, so that's 133.333. Now, it's always important to think about your units. So that's why I like to think of it like you're graphing a curve. So what was your y variables in?
Force.
Yeah, it was pounds.
Force.
What were your x variables in?
Miles.
Miles. So that means I have,
Pound miles.
right, mile pounds. Mile pounds.
Mile pounds. No.
Okay, now your book doesn't care if you leave it as mile pounds. I think it's a little weird. Like you always hear foot pounds, not mile pounds. So I don't really care as long as your units are correct.
Pound every mile.
So you have to put units on your homework. Otherwise I have no idea what your units are. So if you wanted to convert this though to foot pounds, think about it. If you had 133.333 and that was with mile pounds on top, oops, mile pounds, how would you convert so that it's foot pounds? You'd put miles on the bottom, 5,280, I heard Ben say it, so you'd multiply it out. So if you wanted this in foot pounds, if you multiplied it out, you get 70,000, oh no, 704,000 foot pounds.
Wait, is it 1 mile on the bottom?
Yeah, it's like 1 mile
Oh, so
or 5,280.
you
No, you don't get a point for
didn't
that.
write
All right, so I'd probably leave it as foot pounds. All right, same thing for the next one. So I'm integrating. My force is 10 over 1 plus x squared. And I'm going from 0 to 9. So from the origin to 9 feet. Okay. You can do this with Math 9, but let's say that you didn't have your calculator. This was a non-calculator question. How would you do it? Uh-huh. It is 1 plus x to the negative 2, but then what do you need to do? Nope. It's kind of the opposite of chain rule, the u substitution. Right. So you're going to let u be 1 plus x. So du is just 1 dx. So when I replace, I have u of 0 to u of 9, 10 over u squared. So I'm going to pull the 10 out to the front. I'm going to have 1 over u squared, which is u to the negative 2, du. Do you understand? Well, u of 0, if you plug in 0 into your u equation, you get 1. If I plug in 9, I get 10. When I integrate, u to the negative 2 is going to be u to the negative 1, right? Add 1 to the power with a negative 1 out front. I still have that 10 out front too. And I'm going from 1 to 10. Okay, so this is like a negative 10. You can pull it all the way out to the front. U to the negative 1 is 1 over u. So I have 1 over u going from 1 to 10. So just, you'd have 1/10 minus 1, so that's negative 9/10. So then multiply, so you get 9. And then what is your units? What are they? Foot pounds, you see. So 9 feet pounds, foot pounds. Have you guys not heard that unit before? Foot pounds. What was that? All right.
Oh, no.
Slugs. Oh, we're good.
Remember the slug unit?
All right. The slug unit, is that what you said?
Are we-
slugs?
We're not gonna do that here, are we?
English metric.
All right. So Hooke's law. So this is the part I always hated about work. Was Hooke's law? I always thought it was kind of hard. Okay. So Hooke's law states, states that the force required to maintain a spring stretched x units past its natural length is proportional to x. Have you guys talked about directly proportional, inversely proportional? Have you guys heard those words?
Nope.
Yeah, this is directly proportional. This should be a capital F here. So capital F of x equals some constant times x. Okay, so that constant is kind of like the, I don't know what you call it for a spring, like the stretchiness of the spring. It just depends on that particular spring. All right, so it says, therefore, the work required to stretch a spring from length A to B this is your force. So it's same thing, f of x dx from A to B. Okay, so we need to find, you always need to find the like stretchiness factor. So it says always, make sure you always find k first. You like those technical terms?
I'm gonna write that one down. Straight.
Well, you know, when you're pulling springs, strings, when you're like stretching them out, you know, some are really hard to pull apart and some are real easy. Like slinkies just like fall apart.
Can we bring springs into the AP exam?
No. All right, so it says a force of 10 pounds stretches a spring 2 inches. So we're going to use that equation f of x equals k times x. So I have 10 equals k times 2.
Are we splitting up the tests? Or no? We're gonna have all these formulas and then the other tests.
You're the ones that wanted the multiple choice on there. You wouldn't have had to know these formulas.
Wait, you said we're doing multiple
No, I thought we voted that we were just.
Oh, you're just doing 3?
Yeah.
Okay,
choice.
then yeah.
Like,
He
I
is the
wanted
one that
class
wanted
to
that.
be
I
teacher,
wanted
but
just-
he's the only one.
We wanted
Yeah, so you won't need to know these. All right, I don't think I've ever seen this on a AP test, by the way. But it's definitely a calc topic. You always have to do this in calc classes.
Yeah.
All right, so it says find the work done stretching the spring 3 inches past its natural length. So 0 is always its natural length. And we're saying 3 units past, so 3 inches.
Can't stop.
Okay, so I have, since k was 5, that means my force equation always has that same factor, the 5 times x. So that's what I'm putting here, 5x dx. Yeah, they're real easy to integrate, but they're kind of hard to set up sometimes. All right, so I get 5 over 2 x squared going from 0 to 3. So 5 over 2, just pull it to the front. I have 3 squared minus 0 squared. So 9 times 5 over 2. So it's 22.5. What are my units? Inch pounds, right?
8 pounds.
So you can leave it like that. So like I said, your book isn't very picky about that, just as long as you have the correct units. So if you wanted to switch it to foot pounds, which is more common, what would you do to convert?
12.
12 where? Top or bottom?
Bottom.
Bottom, because inches what's on top, so you need 12 inches on the bottom, 1 foot on the top. So that would be
1.25.
1.875 foot-pounds. Okay, so here's where they get tricky. So let's look at number 2. So kind of think about how you'd set that one up first. Let's see where I'm at for time. Oh, 10 minutes.